Good afternoon, everyone. So welcome to this afternoon track of today's regional user meeting, which is focused specifically on R and clinical trials. And this is organized by the Basel Biometric Society, short BBS. That's why you see this also up there on the slide. So first of all, thanks to all the presenters and chairs that followed my invitation. And I'm very happy that we will have 4 invited sessions. So thanks for coming to Basel today. And each of these 4 sessions will be 1 hour long in total. And we will start each session with 3 input talks. They will be 10 minutes long or short, maybe. After the input talks, the chairs might briefly give a short introduction to the following panel discussion, right? So 3 input talks, 10 minutes, 10 minutes, 10 minutes. Maybe a short intro from the chair. And then we jump into the panel discussion. So there you have really the time for questions and answers. So please hold your questions during the input talks. Don't jump into the input talks. We will do this all during this 30 minutes interactive panel discussion, okay? That's the main thing to remember. Hope you enjoy it. And I have the pleasure to chair this first session now on Shiny dashboards for clinical trial data, as you see it here. And our first input talk is from Michael Thorpe, data scientist at Roche, based in Basel. We're looking forward to your input talk, Teal and R Shiny framework to unlock the power of interactive data exploration. So welcome, Michael.
Thanks, Daniel. Can you hear me? So I have 10 minutes to try and give a nice overview of Teal as quickly as possible. So I'm working as an analytical data scientist at Roche, working on clinical trials. And Teal is an R Shiny framework to really unlock the power of interactive data exploration. So just a quick agenda. I'm just going to give you an introduction to the Teal framework, a bit of a Tealverse product map, how we use Teal in clinical trials, and then just some additional resources around Teal and where you can look up further information. So as part of working on clinical trials as a data scientist, there are often a lot of requests that we get from our stakeholders in terms of generating outputs. This is kind of the main part of our work, I would say. And really, we're looking at different ways we can analyze the clinical trial data and try and improve the efficiency in how we work, and also how we interact with our data. So typically, we'll have kind of pre-specified outputs that we need to deliver, such as a Kaplan-Meier plot on overall survival per the statistical analysis plan. And often there can be a bit of back and forth with the stakeholders and the study team. They can say, oh, we actually want to look at something else, like a different parameter. So after a week or so and some emails exchanged, we may also need to generate a progression-free survival plot, which is as a bit of an ad hoc analysis. And then after further emails and a bit more back and forth, they may say, oh, we're just interested in looking at a subpopulation of this. So we then have to generate another plot. And this is really where Shiny can come in. We can kind of try and improve some of the time and the resources that we spend and build a Shiny app that could solve all of these different issues and different problems. So this is introducing Teal. And here's a demo where you can see that we can generate all 3 of these outputs in about 20 seconds based on the Teal app. So just changing the parameters and some of the encodings there. As you can see, pretty quick, pretty easy. It dynamically filters very easily and is very efficient. So what is Teal? So Teal is the R Shiny-based interactive data exploration framework. It's formed of modularized and standardized building blocks and is made up of a collection of specialized R packages which all serve a slightly different purpose. And this really streamlines the creation of Shiny web apps. So it offers that dynamic filtering facility, a bit of code reproducibility, as well as a reporting engine and many different data summarizations and visualizations. So you may even be able to please everyone in the study team, and they may be able to look for whatever they want just based on the Teal app. And now I'm just going to go through a bit of the anatomy of the Teal app. So this is kind of what an example Teal app looks like. It's all customizable, so you can make it as complicated as you want or as simple as you want. At the top, we just have the header, and then we have the menu with the different tabs. And each tab really represents a different module, which can be loaded or unloaded into the Teal app. Then we have this reporter functionality, where you can select different outputs and add them into a general kind of report, which you can then download after. And then on the left, we have the encodings panel, where you can specify the parameters that you want to look at and you want to display in the outputs. We have down at the bottom, the show R code and the debug info buttons, which are newer additions. And that allows you some kind of reproducibility and also the potential to debug any issues that you do have with the teal app. And then the main centerpiece is the output, which you can kind of customize a little bit and make it as nice as you want or as complicated as you want. And then on the right, we have the filter panel, which is very useful, especially the kind of overall filter, the active filter summary, so you can really see what in your data set you're selecting at any one time. And then at the bottom, we have the footer. And then we also have the options to toggle the filter panel, as well as just kind of increasing the view and dimensions, as well as some download capability for that individual output. So how does teal work? So a traditional Shiny app you can think of similar to a truck, in that you load your data set and your UI and your server into one package, and you sort of just dump it all at one go. Teal is kind of structured more like a shipping container, I would say. So each kind of module represents a different container, and you can unload and choose what you want to unload from the container at any one time. And this means that it offers a lot more kind of flexibility in how you're loading up your Shiny app. So it's data agnostic, it's flexible, it's cumulative, and very collaborative as well. So you can have multiple different developers working on different modules at the same time. There's no overlap. And it means that when you're actually loading up your Shiny app as well, it can kind of automatically render very quickly, just based on that specific module at any one time. And it is all open source as well, so there's a good crowdsourcing element. There's the option to customize modules and develop your own. So it really benefits from kind of that user feedback. So here's a bit of an overview of the Teal Universe products map. So there are these specific packages which serve to kind of render the front end, I would say. So these are just the kind of UI of the Teal app. And then there are the Teal modules, which are sort of the main part of the Teal app. And these specify the outputs that you generate, and they all serve slightly different purposes, with the Teal modules general being the kind of general use case that you have. And then on the back end, there are specific packages as part of the Farmverse, so Tern, Osprey, Goshawk, and Hermes, which then feed into the Teal modules. And all of this is kind of packaged together to create the overall Teal app. And here's just a description of some of the framework packages on the left and the modules packages on the right. And you can see there are quite a lot of different use cases. So originally this was developed for clinical trials, but there are also the potential to use it for biomarker analyses and RNA sequence analyses. And it's kind of expanding the use case wherever we can, really. So uses in clinical trials, where this kind of originated from, is mainly for the QCing of the output reports, for trial monitoring, as well as for ad hoc analyses, I would say, as kind of main use cases. But outside of the trial reporting settings, we've had kind of different feedback from various users. We found it's been used for operations analytics as quite an odd use case, as well as exploring like high-dimensional biomarker data. And in general, the modules themselves can be used for many different purposes because it is so data agnostic. So it's a very flexible framework. And there are some example apps, so you can load them with the Teal Gallery package. They're also hosted publicly, so anyone can go and play with them and have a look. And I will be doing a demo after where I can show some of these apps as well. And yeah, Teal is part of the Farmverse, which we've heard about quite a lot today. But there's much more information on the Farmverse packages website. And there's also a Slack channel, and as this is all open source, we kind of appreciate any feedback that we can get. So you can raise issues directly on the Slack channel or on GitHub with new feature requests or any bugs that are found. And there's going to be an upcoming course on Coursera, hands-on clinical reporting using R, which is targeted for Q4 2023. And yeah, finally, just to say, just as some acknowledgements for the many different people that have worked on Teal. It's been a long project, which has sort of grown out over the years, so there have been many different hands that have really helped. So thank you to everyone. Yeah, I think I've managed to do it. To see the timer.
Okay, super. Very good timing, very good timing. Thanks, Michael. Next, we welcome Elias Laurin Meyer, a statistical scientist at Berry Consultants based in Vienna, who presents his input talk, an interactive R Shiny app for visualizing tidy long data with an application and platform trial simulations. Thanks.
Okay, thank you, Daniel. Thanks for having me. I'm going to tell you a little bit about a small Shiny app that we developed within the EU Pearl project, which, as you might or might not be familiar with, focused on platform trials. And simulating platform trials is one of the main challenges there. I'm going to allude to that. And in this particular setting, we had some manual workflows that became very infeasible, so we decided to develop a small Shiny app for that. I should also mention that this is a collaborative effort. One of the other programmers is sitting over there, so any questions that you have, please direct at him and not at me. and also 2 people from the Medical University of Vienna, Franz König and Konstantin Kumaus. Okay, so for those of you who are this doesn't seem to work. Okay, thanks. I'm just too stupid. Okay, thank you. Okay, so for those of you who are not familiar with platform trials, so they have a few very distinctive features. One of those is that they are usually multi-armed trials, testing several different investigational arms against a common control arm. Each of those investigational arms usually has a lot of adaptive features, so could have multiple interim analysis or adaptations. Also, the treatments do not all have to enter in the beginning of the trial, or we don't even have to pre-specify in the beginning of the trial when they're going to enter, so they can just enter in a staggered manner whenever they become available, which was particularly useful in the COVID pandemic. And yes, as I mentioned already, the control arm is shared by several treatment arms, and it might also change over time. So there's a lot of adaptive features in platform trials, which makes simulating those trials quite complicated. So here's just a very brief overview. If you had a regular frequentist fixed sample trial design with one-to-one randomization, no interim analysis, you might not even do simulations because you can just calculate the power based on assumptions such as treatment effects and design choices such as sample sizes or the statistical test you're going to use. And as trials become more adaptive and have more and more features that they involve, for example, let's say we have a Bayesian adaptive design, you can see here in the middle column, don't focus on all of this on the slide, just look at the parts that are in red, because those are the additional simulation input parameters we have compared to the previous design that we had. So there's more simulation input parameters, and then on the right-hand side, there's more simulation output parameters that we're interested in evaluating. So when we look at a platform design, again, don't focus on what exactly is on this slide, just focus on the fact that this list becomes longer and longer. There's just more simulation input parameters and there's more simulation output parameters. And this is the only thing that matters here. So we in theory, in such a simulation study for a platform trial, we might look at 20 or even 30 simulation input parameters and be interested in seeing how those affect the operating characteristics of the clinical design. So remember that I talked in terms of simulation input parameters and simulation output parameters. So a typical data structure we would expect after simulating such a trial design is firstly, somewhere we would expect multiple columns with the simulation input parameters that also tell us the values that they took for this particular replication of the trial. We might have multiple columns that specify the output that we're interested in, for example, trial duration, or how many of the treatments succeeded, how many treatments failed, and so on and so forth. And either we already have this in an aggregated manner across, let's say, 1,000 or 10,000 replications of this trial, or we still have the individual replications there as well. So both happen in practice, and the Shiny app that we designed should be able to deal with both of these types of data sets. Okay, so we started off, of course, by visualizing the results manually. So we simulated the data. We had a very big data set where we varied 20 or 30 simulation input parameters, and then questions would arise such as what is the impact of this particular dimension, what is the impact of another dimension, or what is even the joint impact of several dimensions at the same time. So again, do not focus on what exactly you see in the plot, just focus on the fact that they are quite similar. So they only differ by the fact that we have different variables by which we sort of stratify in the columns of this plot. We have different variables by which we stratify in the rows of this plot, and we're showing slightly different operating characteristics here. But generally, the anatomy of these plots is very, very similar. And if we looked at the R code of doing this, we would see that the problem here is that when we have 20 or 25 simulation input parameters and they all take different values, then if we want to show the impact of just one dimension, for all the 24 remaining dimensions, we need to set one fixed value, because otherwise we would just have noise in our plot. So for 24 simulation input parameters, we would fix them to some value. So let's say sample size of 100, using 2 interim analyses, using these and these Bayesian decision rules, and now looking at the impact of how many treatments do I have in the platform trial on something like power. But so we would have to basically filter out all the simulation variables that we're not interested in for a particular plot, and then add sort of the dimensions in a grid, for example, or as line types that we're interested in. So creating plots like these is very stupid copy and paste work in the end. So you're just taking this, you're copy and pasting it, you're changing some variables, you're putting the variables somewhere else, and if you have 25 of those, this is really not fun to do, especially if in the beginning you do not know what you should focus on, because the whole point of the simulation study might be that you're investigating 25 different dimensions and you don't know a priori, okay, I want to see the impact of these 2 dimensions, but you want to play around with it and see where you find patterns. And then this becomes very, very inefficient. So this was sort of the setting where we decided we want an R Shiny app. And this R Shiny app should, as I mentioned before, we should be able to upload data in an appropriate format. So this should be CSV files, and the only requirement that we have of this CSV data structure is that the input columns should be clearly separated from the output columns. Then if we have individual replications, we might also want to investigate the distribution across these individual replications, or we might want to have some sort of inbuilt feature in the app to aggregate across all these replications. Then, and this is sort of the crucial part and sort of the thing that makes this app worthy to mention, is that we have this option to set default values. So for each of the simulation input parameters, we can set one default value, and then later when we build a plot and choose, for example, okay, I want to see the impact of sample size on the x-axis, what it does in the background is it sort of automatically unfilters for this one variable that we chose to be on the x-axis. It unfilters and doesn't set it to the default value that we chose. So this just grows, and if we have several columns or several rows, it gets unfiltered for those. But very quickly, if we now don't want to have sample size, but some other, let's say, continuous variable on the x-axis, if we remove sample size, it gets filtered again for sample size, and then we add this other variable, and then it gets unfiltered for the other variable. So this happens on the fly. Then, of course, we would also want to have the option to have this interactive using Plotly. And finally, we would want to be able to customize the plot, so add custom labels, resolutions, colors, and so on and so forth, and then download this. Okay, so just as a quick example here, so let's assume we wanted to design a platform trial where we have 1 control and 6 treatment arms with a binary endpoint, simple Bayesian decision rules, multiple interim analysis, equal allocation, using all control data, so pooling the control data. Again, the details don't really matter here, but now we have 3 dimensions that we want to investigate the impact of, so different patient recruitment rates, different treatment effect profiles, and different assumptions regarding the staggered treatment entry. We simulated this using Fact 7.0 platform trial simulation engine. We plugged this into the Shiny app, and I'm just going to show you the final results here so you get a feel for how the app looks like. So we have a plot which looks similar to what I've shown you before. And then here in the bottom, you can see that, for example, for the x-axis variable, now we can choose which of the simulation input parameters should go there. For the columns and for the rows, we have different parameters that we can add there, and it sort of automatically filters and unfilters as we select it. And of course, we have many other aesthetic features there as well that we can set. And for example, color is sort of a flexible parameter. This can be both determined by output characteristics. So if we have several metrics that we want to plot, as it is shown here, then color will be automatically assigned to the outputs. But we can also choose color as one of the sort of input grouping variables if we want to show the effect of one other dimension. And this very similarly works for checking distributions or associations between 2 particular parameters. So really the summary here is that this was developed with one specific goal, and that is that if you have a clinical trial simulation study with many different simulation input parameters, how can you efficiently sort of explore the results that you have if you don't know a priori which dimensions interest you? But in theory, this is applicable to any long data set that meets the requirements. Then the plot is sort of modular, and you add more and more aesthetics as you go. You set the default values. And I should also mention that this is open source on GitHub. It's under active development. It has a GPL3 license. And so far, there was very little manpower spent on developing this app. So it was just like a go-along app to this one particular use case that we had. Yes, here's some references and some contact. Thanks for your attention.
Very good timing as well, thanks. Finally, we welcome Tiina Kirsilä, Associate Director Biostatistics, and Karin, Meiser, Director Biostatistics, both at Novartis, based in Basel. The floor is yours for your input talk on why and how we implemented a question-based communication app framework. Thanks.
Yeah, thank you very much. It's my pleasure to talk today about this app concept that we've developed that is a bit different to what you usually do for apps that work on clinical data. So it's actually not one app, but an app framework. So it allows to create apps in a quite efficient and quick way, actually without knowing any R or Shiny. And in addition, it also has a focus on communicating results. Again, which is a bit different to what is typically done, where the focus is more on exploring data with Shiny apps. To implement this reporting aspect very efficiently, we combined it with a question-based approach. And to get started, I will introduce you to what we mean by a question-based approach. So it's essentially a back-to-the-roots concept, as all research is question-driven. However, in our often complex working models with many people involved, for example, in a clinical trial, we might lose this connection to this initial set of questions. And this concept is trying to re-establish that. It can be used in different phases of a clinical trial, planning or other aspects, but what we will focus on here is now the reporting, the analysis part. So when we have implemented it, we found a few key elements that are important for a question-based approach. First of all, the questions need to be explicitly stated and documented. So we will sit down with the clinical team and brainstorm with them, what are the questions that you want to answer in this study? And then just writing them down and aligning on the wording is already quite a great step in getting alignment on where we want to go. And then if you use, for example, mind maps to write down these questions, you often quite quickly see this underlying hierarchy or connection between the different questions. And this, to visualize this, is very helpful to get a sense of these connections and helps a lot in prioritizing, or needing to prioritize things. Another important aspect is that questions and then also the corresponding answers are understandable to all in the team. So should avoid using technical jargon, a lot of abbreviation, but really using plain language as much as possible. The last aspect is that all analysis should be focusing on answering questions. And for that, we found it most helpful to disentangle the different steps. So first of all, think about the questions, and only in a second step, think about what analysis are best answering these questions to really find the ones that are appropriate for this. And then yet again, in the third step, think about how to present the results. Now, the remainder of this presentation will be talking about this last aspect of communicating the results. And with that, I hand over to Tiina.
Yeah, thank you, Karin. So I just want to re-emphasize a couple of things that I think Karin already mentioned there. So that once we talk about the app framework, we are not talking about a sort of a classical Shiny app, which would be a single Shiny app, but rather we have a framework which contains a collection of R packages where the separation of tasks is very clear. And this allows us to have a solution that is reusable again and again by different teams, and it's easily extendable if there are new needs that arise. And another sort of separating factor, which I already see from the previous presentations, is that we are not focusing on exploring the data. I'm not saying that there is nothing bad with exploring, of course, but I mean the separation here is that it's a communication tool. So we actually have very little interactivity in our framework, but it's really a matter of communicating the results. So I know it's a bit busy slide, but let me walk you through it. So here would be a a typical framework, the workflow of the framework, how it would go. So at the top you have the roles. So there are 3 roles involved in implementing a QBA. So there is the framework developer, a statistician, and the clinical team. And at the bottom you have the workflow for the development. So that's sort of a separate workflow from anything else. So yeah, as Karin mentioned, everything starts with agreeing on the questions. So that's the first step, and that happens between the statistician and the clinical team. And as a next step, I mean, once at least the initial questions are agreed with the team, the questions would be sort of handed over to the statistician, and then the statistician would be identifying the relevant data to answer those questions, and also defining what would be the best way to visualize that. And that's usually sort of at the core of being a statistician, like knowing what data and how to present it. But here, I mean, sometimes the statistician don't have the technical knowledge of how to actually program that. I mean, in this audience, I don't need to sell anything by saying that you don't need to know how to program. But that's, at least I still have colleagues who do benefit from the work here we are presenting. So in order to build the visualizations, the statistician actually doesn't have to have any R or Shiny knowledge whatsoever, since all the questions and the answers are built with this question builder. I will show you a quick look at that in a few minutes. And then if there are any new visualizations or changes to the infrastructure needed, that would be communicated by the statistician to the developers, and then that would be sort of the only input flow from the developers. And last but not least, of course, there would be a separate Shiny app, which would be project-specific to that specific clinical team, and that would be released. And then, as said, I mean, it is reusable completely. So one could have running numerous clinical trials parallel using the exact same code, and that can be used by many different clinical teams at the same time. And at the end, every clinical trial would have their own specific app, which is still using the exact same code which is underlying. So here is a quick glance of what does a QBA app look like. So this is the one that would be visible to the clinical team. And this is also the app that I will be showing in the demo later on. So here, I mean, I'm not sure whether it's fully, I think it's okay. So there are a few tabs which are always fixed, which is the key insights, additional insights, and the deep dive. So in key insights, as it says, you would have the key information that you think it's relevant for, like, at the core. And then at the right side, you would have the deep dive, which would contain all the questions for that project. And as said, with this framework, you actually see very little interactive pieces. So within each sort of card, if you will, there is one question, and there is one visualization that is answering that question. And I mean, I think it's only human nature that while seeing something like this, new questions arise. I mean, I actually want to see something else, and then you would just add a new question to that. So yeah, this is the one that would be visible to the clinical team. And here is a glance of the question builder. So this is the tool that the statistician would be using. So it's not the same app as what the clinical team would be using, but this would be sort of a back-end app, if you will, that would be used by the statistician to build the questions. So yeah, it's a graphical UI. It's a Shiny app, as you can see. So here, the statistician would be defining the specifications for reading, merging, and manipulating the data. But this is done with the user interface. So as said, no programming skills required. And yeah, out from this app, the specifications entered by the statistician would be exported into a JSON file that would be then used by the core code, and from there, the clinical trial specific app would be deployed. And yeah, here is a few lists of projects where the QBA has been used so far. I can maybe highlight a couple of them. So at the top is the COVID-19, which is sort of a, I would say, a classical pooling activity with 4 internal trials. Then in the middle there is HS, where we benchmarked internal data to competition data. And another sort of extreme is the lupus, where more than 50 competitive studies were compared. And one thing which I want to highlight here is that all of these activities require merging different data, and at least to me as a statistician, that's always a hurdle, how you really merge the data correctly, and with this framework, it's actually super easy. And last but not least, I would like to acknowledge our colleagues, the developers, Andrew, Harvey, and G, and statisticians, Astrid, Tirta, Ilona, and Ovidiu, and also other QBA friends. We have a couple also in the audience. So with that, I say thank you, and looking forward to the panel.
Okay, just very good. Thanks all the presenters. That was very, very cool and very much in time. So I'm very happy that this worked out well. Very good. So before jumping into the panel discussion, just a few, motivating slides from my side. The one slide I want to show is actually it's interesting how how old or young actually Shiny is, right? So let me. Let me go back. Oh, so my heading is not here, but that's okay. So basically, the history started basically 11 years ago. So I learned when I went on YouTube and looked at Joe Chang's presentation, which I can very much recommend, The Past and Future of Shiny, that he gave at our studio conference last year. In 2012 in July, there was like a JSM session, and it was not even a scheduled presentation. And apparently the last 10 minutes of some other presentation, he borrowed this time, and he showed the first time Shiny to the world. And from there, it just kind of skyrocketed, right? And for example, last year, they presented Shiny for Python, so now it's not just for R, but it's also possible in Python. So I think that was very interesting to think about this. Also, the other thing is, when you think about the recipe for the success, it's also very interesting that at least Joe was also explaining that, it's really that you have this simple HTML interface that you actually don't need to use HTML. You just basically program HTML using R, right? On the one hand, and then on the other hand, also this whole reactive logic on the server, again, you just use R, right? So you can stay in pure R, and those two, this interface and the server, are just connected very easily, and it's very clear. And that's really kind of the recipe for success. And so watch this presentation. I think it was very interesting to see the story behind that, because you will find out that actually Joe Chang almost kind of quit our studio, but then he kind of stayed with it because of this kind of magic invention that he had. And forward 10 years, here we are. So we talk about Shiny dashboards for clinical trial data. This is actually taken from the Epsilon website. I took this graphics. So we have lots of different Shiny apps for lots of different purposes, and also for clinical trial data. We talk about this today. We saw some very interesting. Saw two interesting frameworks, I think, for analyzing clinical trial data. We saw one very interesting framework for actually for designing trials, right? Because simulations are used for many clinical trial designs. So so with that kind of thoughts. Let's jump into the panel. So welcome all the speakers again on stage. Okay, and then you will also, of course, get your questions. So let me start with one starter question, and then we will open up already for the audience, and then I will, if there's no question from the audience, I have a few backup questions. Okay, good. So basically a starter question. So, how much have these apps actually made your work more efficient? So is it really worth this effort? Like, is it worth doing all of this? And then we can just go around maybe.
Yeah, from a data scientist perspective on clinical trials, it's definitely worth the effort. It's taken a lot of the front loading, I would say, off the developer. So you can kind of cool these modules down from verified packages. And it means that even if you don't necessarily know that much about Shiny, about building your own UI and server, you can just go into kind of some of the documentation and cool down a module, and then you can generate a very nice looking Shiny app without necessarily decorating it or spending a lot of time sort of adjusting things. So I think definitely it's a huge improvement for a developer.
Yeah, Elias?
Yeah, so I would mention maybe mostly that it made it much more enjoyable now to work with the data, because I wouldn't know at this stage, since I mean, the Shiny app is quite young. It doesn't even have a name yet. So I wouldn't say that at this stage we saved a lot of time programming the Shiny app compared to actually doing the things manually. I guess that will come with time, but at least it made it much more enjoyable to work with the data. And when we have new simulation results, we can just plug it into the visualization tool, and we get results quickly versus loading it, writing ggplot code.
Okay, thanks. And Tiina and Karin?
Yeah, I can first start and Karin then can continue. I mean, for me, I mean, I'm almost like childishly enthusiastic about the work we have done, since it is just like solving so many pinpoints, which I know are common. So that's one thing. I'm not sure whether it has sort of paid off yet so much, since I mean it's still in the development phase. I mean it has paid off to the where we have used it, but I mean we are still sort of contributing to it sort of part-time, I would say. So I mean it would be like imaginably great if we would have more resources to really like make it big. But Karin.
I think for an individual statistician, I think it's really quite a quick way of creating nice graphs and being able to create a Shiny app without being an expert in Shiny, I think is the other aspect. So for me personally, it's quicker to do a graph there than really think about all the settings and things and start from scratch. But yeah, so I think in that sense it will be and is.
Okay, thanks. That's interesting. Okay, and now I'm sure you have a lot of questions. So we will start with the first one.
My question would be, how do you handle the validation topic? So because if you're dealing with clinical trial data and you want to later on bring these results into a report that you hand over to a regulatory authority, how do you validate your Shiny dashboards?
I can start, or yeah, I mean, so far not. I mean, it's used for internal only, and I mean, I think this is another pinpoint that I'm curious to see what are your responses, since I think that's also a pinpoint, since I mean, it's sort of, we have the official outputs and then we have the sort of the, well, I'm going to use the word exploratory, although we don't actually use it, we use it as a communication tool, but still internally only. So far, we haven't made that sort of connection, but I think it's one of the most relevant questions, since I mean, what's the purpose of like creating these nice things if you're just using them internally?
Yeah, maybe Michael can continue, yeah?
Yeah, I think, so currently teal is very much exploratory use, and that's what it's designed for. It's not designed for regulatory stuff, but it's very useful for any kind of ad hoc analyses. I think long term, the goal would be to have it just generate a teal app, and then that could be submitted to the regulatory authorities. But currently, yeah, it's mainly just exploratory use.
Just add one aspect to it. Yep. I think what it helps us to do is to do this more exploratory, but we have the questions which already help to go into the right direction, hopefully. But still, then the team usually picks a few things that then are reproduced for a CSR, say. So, but this limits already the amount of things you need to really validate that way. So that's how we do it currently. Yeah.
Filtering it down. Okay, next question.
So, hello. You mentioned that it was used for internal decision making. Can you maybe share your experience, if there's any, on how it could make patient decisions, maybe perhaps dose escalation?
Okay, so some examples on internal decisions. What kind of decisions did you maybe make internally, besides selecting which outputs to use?
We both work in the early development part of Novartis. So the main decision that we have to take after a POC study, proof of concept, whether to continue development. I think this is what it's been mainly used for. We haven't really implemented it to make decisions during a trial, so I think it would be possible, but it hasn't been done yet.
Michael, anything from teal side?
From the teal side, I mean, I'm not a statistician, so from a data scientist side, I think statisticians probably could use it to make some internal decision meetings on, sort of if you're looking at a subpopulation, or maybe for kind of a new trial design, but I'm not too aware of any examples myself.
Yeah, maybe I can add, because I'm also a little bit familiar with teal usage. So I think it also has been used, for example, for the study results meetings, right? So when you talk with high-level management the first time, look at the results, and typically there will be some questions, yeah, but how does this subgroup do, and how does this the other one do, and so on, and then you can very quickly answer this with the teal app. So that has been also, I think, also very useful. Yeah. Other comments or questions?
I very much like this app framework. and because whenever you show a graph, the next question is around the corner. So one question would be, how fast is the turnaround for the new plot? And the second question is more a technical question that has something to do with the submission readiness. Is it possible in your tools, or do you think of making it possible that the code that was used to generate the results is just produced while with a print, that you can have the code presented to the people?
Okay, so there was one question around how quick it is to generate the next plot, and one question on the reproducible code.
So I can start off with the turnaround, and the short answer is it depends. So, if it's let's say if it's a chart for which we already have the layout. So let's say it's a bar chart, it's a line plot, it's a heat map, or whatever. If it's like fitting into that formulation, it's very quick. But if it's like out of the blue, something which we don't have as a visualization, I'm not. Karin, can you give me an example for which we don't have a content module yet? Yeah. So let's say a Sankey plot. For that we don't. I mean, it's in the making, let's say. But for that we don't have the content module to create that. So for that it would take more time. Since there is in a content module, and then there is this back and forth with the statistician and the developer. Whereas if it's a new question where you can use a bar chart, a very simple one. I mean, the questions it can answer can be very different. So if it's a bar chart for which we have a content model, it's very quick.
Is it a day? I think less than a day, because you need a few minutes to create it, and then you need to redeploy the app.
Yes.
Probably within 15 minutes if you want.
And the second question was around the reproducible code that you can get from a button.
We haven't implemented that, but we have thought about this. But I think it should be possible, but it's not available so far. Yeah.
Michael, maybe comment from Teal's side.
For Teal, it's very easy. So there's a nice button. So you just click on that, and you can. It goes into the back end, and you see the packages. So it kind of displays all the packages that are used, and then how the data set's manipulated in that, and some of the functions that are used. And it prints out in a nice PDF for you.
Next question. I think we have one over there. Was it correct?
Yes, I have a question. Sorry.
Okay.
Yeah, I'm here.
There you are. Good.
Yeah, actually, I have a short answer for the question about Teal for the submissions. And today I will present something about the TLG catalog, which is and the biomarker catalog, which is something that we are aiming to an end-to-end R filing for this year. So from raw data to tables and lists and graphs, which sort of answers that question, on which Teal is based, roughly. And the question instead is, I was thinking that maybe, I was wondering actually, that let's say a language model, let's say having a question-based analysis, it could be a bit limiting the potential exploration, right? Because you have still a fixed number of possible analysis paths. So I was wondering if you think you encounter this limitation, or you think it's exhaustive enough?
I mean, my answer would be, it would be that's by design. We actually want to limit, since usually if you have too many options, people. I mean, that's at least our expectation. Well, experience with the clinical teams. If you actually give them like explore what you want, they get overwhelmed. So that's why we have, on purpose, limited it. So I mean, it's. But I mean, I can see both like advantages in both. Sometimes you do want to explore, but sometimes you want to limit.
It's clearly a communication tool, right? So we allow some user interactivity, some things you can change, but they still, or we deliberately decide which ones to allow so that they still answer this question. So this is why it's limited. So it's really by design, as Tiina said.
I think Hans-Jürgen had a question. Sorry, or should I give him mine? Okay, thanks.
Just one old question on validating. I was a little bit puzzled by that statement that teal is only for exploratory. So to Elias and to you, Michael, I think if you conceptualize such a visualization tool, I think you need to know the way if you can validate or cannot validate it, right? So what is your perspective? I mean, the tools are already there. So you must have in the design specs have an idea, is it possible? How can I do it or not?
Yeah, I think it currently is planned to be validated. So a lot of the back-end packages are now on CRAN. For example, like Turn was recently, which is sort of the main building block for it. And I think long-term, the goal is to have it validated on CRAN. And then you could just submit it to the FDA, for example, and they could just look at any kind of data subpopulation that they want to look at.
So that, for me, means you are saying the concept is such that it is, in principle, ready to get to be validated. Is that right?
Potentially, I think, yeah.
And you don't sound too convinced. Elias, how about yours?
Yeah, I mean, maybe in our case it's slightly different because all the app is really doing is sort of data manipulation and using ggplot. So I guess for us the next step is going to be also, this goes in the direction of reproducibility, to sort of have one button that then displays all the data manipulations and all the ggplot command lines that happen from the initial data set that is submitted to the app. So I guess having this code would then be some sort of validation, because you look at it and it's, I mean, ideally ggplot and dplyr do what they're supposed to do.
Maybe I can jump in with one general question to everybody here, because for me, validation always comes down to like rigorous testing of the software, and the, you know, from unit tests, integration tests, and good development practice and so on. So just a general question, so how are you testing your apps and the modules, and how do you maintain them in general? What are your kind of development building blocks there and so on? So maybe Michael, do you want to start?
Yeah, so for the Farmverse and the teal framework, we follow very much like an agile software development kind of life cycle. So it's all on GitHub, and any kind of tests are built into the specific modules, where we try and test every kind of different feature or different stratification possible. And then, yeah, I think it's just kind of built from that. Any kind of new feature will have to pass like CI/CD tests. And there's an infrastructure team who are kind of working on increasing the validation and kind of getting it more up to speed.
Yes, in our case, so this is a very young and small app, I would say, and I mean the amount of manpower that went into this is really limited. So most of the testing that we had was manual, and really basically just bug reporting and bug fixing at this stage.
Mm-hmm. Yeah, so for us, I can speak about the content models, and there we have done quite some unit testing. But I mean, there are also just by design there are things which are sort of, I'm hesitant to use the word validated since it's not validated, but there are numerous checks that things are doing what they're supposed to do. But I mean, it's not sort of checkbox for like the official validation, I would say.
Mm-hmm. Okay, cool. Other questions, other comments? We have one up there.
Maybe you can take this in the meantime.
Oh yeah, let's do François in the meantime.
Yes, thanks. I very much enjoyed the QBA presentation, and I think it's very much in line with the idea also of formulating the estimates correctly. So in my experience, getting to fully fleshed out question is difficult, and I was wondering if you managed to get the clinicians expressing their ideas clearly in a question or not.
It's clearly a learning process on all sides. I think it depends a bit on experience. I think you can see there a difference. So some people who are more experienced usually are better in phrasing their thoughts into questions, but it's something that we don't train. Yeah? For years we haven't really done that, so it's something to get into. But if you start, people also get into the mode and stop saying, I want this table and I want this summary statistics, but think about the question. But it's a process, it's a learning process for sure. But we do that with our clinical teams, with not just the clinicians, but of course this is a primary contributor, but also getting input from the other experts on the team. Yeah.
Mm-hmm. Thanks.
Thanks. Thanks all for all the presentation. Maybe a question more for Michael, but all the speakers are welcome. Michael, so back to your presentation, you were talking about the static output and you know the old and current way of people to make the static output and change their mind and think more and more and more. Do you have already some metrics about people using teal vs the reduction of static output at the end?
So to reduce the amount of static outputs that you plan for, or to...
Yeah, in terms of really reducing the programming, the validation, you know, back to your point, and all the effort that has been made.
Yeah, so I think currently you'd plan to produce a set number of static outputs, and the teal app could be used to sort of support those outputs from the QC side or from kind of exploratory analyses. But I think if we take a risk-based approach, it would be to try and use the teal app as much as possible and try and verify the information that we see on static outputs on the teal app, rather than producing maybe QC outputs just to verify them as well.
But do you see a real reduction? Because you know many people just ask output just to try to answer a question and finally say, no, I don't need it, change another one. And we have all the time which is spent in current static development and validation, to take back your point. And so I think a big advantage about exploratory of the data is to help people making decisions, to reduce the amount of final work, as we're talking about the validation of deliverables and still doing the final programming for submission.
Yeah, I think definitely. So I think it depends a lot on the stakeholder involved and how willing they are to use teal as well. But I think if they're willing to go and look at the data themselves, then it reduces, you don't have to generate the outputs for them, especially if they're not required for any kind of filing or anything. If it's just for interest, then they can go and produce those outputs in the app themselves. So I think we already see quite a reduction in the number that you would be required to produce.
Thank you.
But it's a good idea. Maybe we have to go back to the NEST team. That could be an interesting metric, like over time, how much has the number of static outputs changed or not. I would maybe close with an open question, if there are no other questions. The very, very simple question. So what are your plans for the future of these apps? And what are the next steps? And so immediate next steps, let's say short term. And where do you see them, let's say, in 3 years from now? So more like longer term. So who wants to start?
Yeah, I think teal's grown a lot, and the Farmverse in general have grown a lot over the last few years. I think originally it started off as just sort of a nice little app that people could create and add to. And now it's very sophisticated, and I think it will just keep getting more and more advanced. And hopefully in 3 years it will be fully validated and able to submit to the regulatory authorities, just as the teal app itself.
Thanks, Elias.
Yeah, I guess firstly making it more reproducible. Secondly, finding a name. So if anybody has, if anybody has any suggestions, and then so for the longer future, so Berry Consultants, the company I'm working for, they have a simulation software, and so this offers some plots basically that come with the software, but maybe there could be sort of an interface for adding it to simulation software.
Good idea. Karin and Tiina.
I covered a long view. You can we are also thinking about using it for DMCs, for example. Also thinking about at some point using it as a submission tool, maybe for health authorities, would be nice. But it's a long way to go, clearly, on our end. Yeah, really, because the short-term goals are.
Yeah, I mean, just to make, just add more content modules, like with regards to the visualizations and so forth, and also getting sort of people. So at the moment we have 6 sort of, I could almost call them like beta testers. So I mean, just sort of expanding that, and of course having the resources for the development team to support that fully. So I think.
And maybe open source.
Well, that's a question to someone with a higher paycheck than myself.
Okay, let's close it with that. So thanks everyone, thanks to all the speakers. Very, very nice. And we're handing